All right, guys, here we go. So today we are going to focus just on one rule, just on the power rule. And I guess you can say constant as well, but the constant one you already know. Tomorrow we will focus on product and quotient. But yeah, today we'll focus on power. No yawning, miss. It's too early. Well, we'll see. It depends on how today goes. All right, here we go. You guys ready? We're going to go slow, guys. You ready? All right, so we're about to learn. I mean, hopefully this one you already know. It's not a big deal. Remember that derivative means instantaneous rate of change, which is just instantaneous slope. Are we okay? Yeah. All right, so this is a rule here. It says if f is a function with a constant value c, then df dx, which you shouldn't be freaking out, that just means derivative of the function. So it says d dx of c, where c is a constant, is 0. Now, you shouldn't be freaking out because all constants, like y equals 5, y equals 10, y equals 1,000, all constants have a slope of 0. Look, find dy dx for the following functions. Y equals 5. What's my slope of y equals 5? 0. So I'm going to write y prime equals 0. Or you can also write dy dx equals 0. They both mean the same thing. Y equals negative 10. What's my slope? What's my instantaneous slope? Or really, it doesn't matter. Slope and instantaneous slope. What's the instantaneous slope of negative 10? 0. What's the instantaneous slope of, I'm not sure if that's 10 billion or 100 million or whatever that number is.
1 billion.
10 billion? 1 billion? Okay. What's that instantaneous rate of change of that?
0.
So the derivative of a constant is always 0. Are we clear on that? Okay. All right. Now, here is a rule. Relax. It says power rule for positive integer powers. Actually, you know what? Erase the positive. It's power rule for all. As long as you have, not necessarily an integer, as long as you have a real number. Power rule for powers of x. As long as you have a real number. Any real number. Not just positive integers. You do that. So so look at letter A. It wants to know the derivative, right? So here's how we would do it first. So I'm going to go real slow. Don't worry, I'm not going to do the rule just yet. So here's how you would do it before. F prime of x equals limit as h approaches 0. And so what do I need? F of x plus h. So I'm going to write f of x plus h is equal to x plus h close it squared. X times x is x squared. X times h is xh. But you have how many of those? And then h times h is? Okay, so here's how we used to do it. Limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. Yes or no? What cancels out? Zeros out, sorry. Yeah. What zeros out? The x squares. And now what can I cancel out now? One of those h's, and then h is approaching 0, so that means this guy's approaching 0. So this whole shebang is just 2x. And then so we would say f prime equals f prime of x equals 2x. Are we okay with that? Okay. The power, and I'll wait for you guys to catch up because I can see some of you guys writing. You don't have to write that down if you don't want to. That's just stuff that we've been doing all this time. All right. According to this, do you guys see this? It says d dx of some polynomial. It has to be a polynomial. Or some x to a number, where n is any real number. Any real number, except 0. Or except, well, it doesn't matter. Because you can also say 1, because 1 minus 0 is 0. All right, so this says you drop it down, and then you subtract 1 from the power. All right, so let's see. I'm going to rewrite it. F of x equals x squared. Following the rule, here it is. I'm going to go slow, guys. F prime of x. Following this rule, look what it says. I drop it down. So this 2, I'm going to bring it down. So if I bring that 2 down, it's going to be what? 2. and then I subtract 1 from the exponent. X to the power 2 minus 1. What's 2 minus 1? So 2x to the power 1, so I can just write 2x. And OMG, I got the same thing as that. You don't have to be all that specific. I'm writing a whole bunch of notes for you guys. All right, look at letter B. I'm going to do letter B. Don't worry, we're going to go slow. Say it again. S. Oh, the first part was the long way, how we used to do it. And then we notice a pattern, and the pattern is this pattern. So now they just give us a formula that we can just use to take a derivative for any power. So, you know what I mean? No? Are you concerned about the sky blue or the red? Yeah, I want to find the derivative of that. The one in sky blue is just is my shortcut. I brought the power down, and I subtracted 1 from the power. Okay, here we go, guys. I'm going to use purple for B. So f prime of x, using my rule, what do I bring down? The 7, and I still have that x there. And then what's going to be my power? There it is. That's my derivative. Yeah, I'm just doing that rule. Good job, Gian. Tell me what I'm going to do next, Gian, on this letter C. Perfect. I subtract 1 from -5. So -6. If I wanted this to be positive, I see you, miss, don't worry. F prime of x is equal, what the heck happened here? Trash. F prime of x is equal to -5 over x to the 6 if I wanted a positive exponent. What's up, Espinosa? Okay. No. Yeah, we're not robots. You were absent a few times, so maybe you don't have enough practice. The reason why we're doing this is because it's a fast way to take derivatives. So beforehand, we would do the limit process, and we always get this. Do you see all this in like light red? Okay, and look what we got. We got 2x. So what people notice, all right guys, focus. What people noticed, they kept taking derivatives of polynomial over and over again, and they were like, there's a pattern. Every time we take a derivative of any x to a power, they notice a pattern that it was reduced by 1, the degree, and they notice that it's a multiple of whatever that degree was. So now, this is the shortcut. So, but remember, we need experience, and you've been out a few times, so try to get some experience with the limits, and then go ahead and jump to this. All right, what's up?
Did you put it over the x to the 6 to make that exponent?
Correct. So, guys, we're probably going to have to do, I don't compare classes ever, but last year's group had a review on exponents, and they came after school for that, or some came in the morning, but the majority came after school for that. If you guys are like them, and every group is different, but since the pandemic, we've had issues with exponents. If you guys have issues with exponents, which is an algebra topic, we might have to create a session after school. So let me know if we can go tomorrow after school. Let me know, and we'll go tomorrow after school with exponents, and we'll do a full-blown Algebra 1 lesson on exponents. Algebra 1/Algebra 2. All right, here we go. So look at this one. Look at letter D. So letter D, we'll figure out right now real quick if we need to do a lesson or not. So we have the square root of x, and you're thinking, how am I going to apply the power rule on that? Well, the square root of x can be written as an exponent, x to a certain exponent. What exponent would that be? Half. So f of x is the same thing as x to the half. Do you guys remember that from your Algebra 1/2? Okay. Yeah. So if it was a cube root, we would write 1/3, right? A fourth root, 1/4. Okay. All right. So next, how do I take this derivative? I drop that half. Drop it like it's hot. Okay, that was dumb. X to the -half. If I want to rewrite this, and I'll go slow, don't worry. if I want to rewrite this to look back like my original f of x was square root of x, I will write it like this. F prime of x equals 1 over 2x to the half. That's me turning it into a positive. And I'm writing a whole bunch more steps than necessary because I want you guys to have good notes. And then I'm going to turn that exponent back to a radical. F prime of x equals 1 over 2 square root of x. Okay. When I brought it down, it turned positive. Yeah, laws of exponents. Yeah, we might have to do a lesson. It'll be optional if you guys want to come in. It's up to you guys. We never make it mandatory. Okay. Okay guys, real quick. Look how much nicer this was. I'm looking at letter D. Before, here's how you would do it. I'm going to do it in sky blue. And if it's up to you if you guys want to put this in your notes or not. Before, I would have to do this. F prime of x is equal to limit, as h approaches 0, of square root of x plus h minus square root of x all over h. Do you guys remember that? And then we'd say, okay, well, we're going to have to multiply by the conjugate of the numerator. So we'd go square root of x plus h plus square root of x all over square root of x plus h. That h is inside there. Plus square root of x. Are we still okay, guys? And then from there, here's what we get. F prime of x is equal to limit as h approaches 0. Square root times square root, the square root goes away. X plus h minus the square root of x times square root of x is going to be x all over h parenthesis square root of x plus h plus square root of x. Are we still okay? Now look, in the numerator, what zeroes out? The x's. Now that I zeroed out the x's, can I cancel out an h? Bam, bam. What is h approaching? So I have, let's see, f prime of x, and I'll write out the steps. Now h is approaching 0, so I'm not going to write limit anymore. I write 1 over square root of x plus the square root of x, because h is approaching 0. X plus 0 is x. What's the square root of x plus square root of x? 1 over 2 square root of x. Yeah, I got you, miss. I knew what you meant. And look at all the work we had to do to get to this, and then look at everything in red. Well, I wrote more steps than necessary. Usually you just go from here to here right off the bat. But I wrote those steps for you guys so you guys can see like the formula being used. Does that make sense?
Yes.
Is this a lot nicer?
Yes.
Okay. How do we feel? So we are done. That's it. That's it for calculus.
Oh.
Now it's just a whole bunch of algebra. All right. So that's where I wrote. Hopefully you're seeing that these are straightforward. Remember, the beauty about math is that there are patterns everywhere. Remember what it means to take a derivative. So here it is. These are my little notes that I typed out. That's my derivative. Because of these patterns, we can now use these rules to just take derivatives in a fraction of the time. And then I put a happy face emoji. Cool or not cool? All right, here we go. Relax. This means the same thing. Look, if u is differentiable function of x and c is a constant, then d dx of cu is equal to c du dx. I always introduce it initially, and then somehow you guys forget, and then I go to trig, and then you guys all want to use product rule. Don't worry, we'll get there eventually. And I'm like, guys, remember from this? And I don't know. So we have like a headache for like 3 days, and then you guys finally come around and get it. All right, here we go. You guys ready? I'm going to go slow. According to this, look, this is a constant. So this is a constant. The c means constant. And then the u is like your variable. So du dx means derivative, right? So by the way, derivative of u with respect to x. The numerator is what you're taking a derivative of, and the denominator means with respect to what. So I'm taking the derivative of u with respect to x. So really I should be writing dx dx. Okay, I'll do it real quick. All right, here we go. I'm going to go slow. I'm going to go real slow. Y prime, according to my rule, it says here that I can go 5. And see, it says c, that's a 5. And then what's the derivative of x squared? 2x. It really is 2x dx dx. It really is that. But what is something divided by the same thing? 1. So usually we don't write dx dx. We just write, so I'll write it right here. What's 5 times 2? We just wrote 10x. Yeah, put that one in your notes because it's going to come in handy when we do related rates and when we start taking derivative with respect to different letters. Are we okay? Have I confused anyone? Okay, by the way, in case you're wondering what is this dx, it means we took the derivative of x with respect to x. So, Chav, what does this mean, dy dx? We took the derivative of y with respect to x. What does du dx mean? It means I took the derivative of u with respect to x, if I write du dx. If I write du dy, it means I took the derivative of u with respect to y. So that's what it means. But don't worry, when we get to that section where we're doing related rates and implicit differentiation and taking derivatives with respect to different letters, I will let you know. I will remind you of notes 9. So I don't know if you want to write like a side note somewhere. All right, here we go. I'm just using the rule. I'm just using this rule up here. Sorry that it got all like cluttered all of a sudden. So here we go. Y prime equals, according to the rule, I can go 7, parentheses, what's the derivative of x cubed? 3x to the what power? Squared. Close it. What is 7 times 3? So y prime is 21x squared. Oh, because I subtract 1 from the degree according to my power rule over here. See how it says n minus 1? So you got to subtract. You know what I mean? Okay. If you're wondering, like, man, this feels a lot like a robot, that's because you're just following instructions. You're just following what that little rule says. Chav, but where did it come from? It came from the limit properties. Are we all clear? So we're not robots. All this came from an observation of looking at polynomials when we take derivatives. Good or not good? Okay, so if you're wondering, like, man, I feel like a robot, that's because you probably haven't done enough limit process. You need to do more of those. All I'm doing is following a rule, guys. Okay, so here is what I tell kids about, well, what I tell everyone, not just kids. Not like a little 5-year-old, because they don't know calculus. But, well, I mean, I don't know, maybe. Okay, no. All right. Here's what I tell anyone who's taking calculus. I used to tutor university students, but I don't do that anymore because I just don't have the time. When I used to tutor, I would just say, well, you can just multiply that 7 times 3 directly. You don't have to do this over and over again. But remember this process, because later on you're going to want to do a different rule, and like you're wasting your time. It's just a derivative of that. But do you guys know what I'm trying to say? All right, so look at letter C. Y prime equals, now let's see if we can do it with very little steps. What do I do? Negative 20 times negative 5, which is what? 100. And then what do I do after that? Negative 5 minus 1, so I'll put an x there. What's negative 5 minus 1? Negative 6. And if someone tells you that they want to have positive exponents, how would I rewrite that? I put a fraction and I move the x to the negative 6 down and it turns to a positive. I'm going to rewrite this. Y prime is the same thing as saying dy dx. dy dx is 100 over x to the... That's a prime. Don't make it look like a 1. It's a little slant little thingy. Y prime. Yeah, apostrophe. Are we okay? All right. Look at number 8, or letter D. Sorry, it's not number 8. It has an 8 as a coefficient, but it's not number 8. All right, here we go. Before you can do the derivative of that, you need to turn that into an exponent, the square root of x. So I'm going to rewrite this. I'm going to write y equals 8x to the power 1/2. Are we okay? All right, y prime equals, what is half of 8? 4, because I did 8 times a half. And then I subtract 1 from that half. What's 1/2 minus 1? Negative 1/2. Get out of focus, miss. All right, so now from there, I'm going to bring that negative 1/2 down. So y prime equals 4 over x to the 1/2. Are we still okay? And then I'm going to rewrite the x to the 1/2 as the square root. 4 over square root of x. Are we okay? How do we feel? Ask. Oh, we're good. All right. Relax. Don't freak out. This just says sum and difference rule. It just means that I'm adding and subtracting polynomials. And all it says is you just take the derivative of each variable. So u means du dx. I'm taking the derivative of u with respect to x. This v here means I'm taking the derivative of v with respect to x. Nothing crazy. Are we in the clear? All right, here we go. So it says find dp dt, relax. All that means is I'm taking the derivative of p with respect to t. So is this function p in terms of t? Does it have t's on it? Yeah, we're good. We can take the derivative. So here we go. All right, dp dt, that's my derivative, equals, what's the derivative of t cubed? 3t squared, and it really is dt dt, but do we write that? No, because the dt dt is just 1. Are we still okay? Yeah, we're okay? Okay. Plus, what's the derivative of 6t squared? 12t. Yeah, I'm just doing that roll up there that says sum and difference. Good job. Minus, what's the derivative of 5/3 t? Well, I don't know, child. That's power 1. Well, the derivative of t is 1. Yeah, negative 5/3. Can you tell us how you got that? Yeah. Okay. Okay. Is there another way? No, that's good. That's good. But is there another one? All right. Side note: don't just look. Y equals 3x. What's the slope of 3x? So what's y prime of this? 3. Remember that derivative means instantaneous slope. Y equals 5x. What's my derivative of 5x? 5. Because it's just a slope, right? But it's the same. They both work. You can do 1 times 5, and then 1 minus 0 is, 1 minus 1 is 0, and x to the 0 is 1, and 1 times 5 is 5 again. They both work. Are we okay, guys? All right. What's the derivative of 16? Yeah, say it. Say it out. No, not 16. 0. It's just a constant. No slope. Well, okay, be careful. Don't say no slope. So slope of 0. Yeah. Undefined slope is vertical line. Yeah, but yeah, slope of 0. Cool or not cool? We're okay? No emergency or anything, right? But she's okay? Okay, if you need to step out, you can. All right. Are we cool, guys? All right. Any craziness here? All right, here we go. Now look, we have an application problem. It's not an extreme one. It's a basic one. It's a baby one. It says, does the curve y equals x to the 4th minus 2x squared plus 2 have any horizontal tangents? If so, where? So hopefully you remember from Algebra 2. I think this one looks like a W. It does have horizontal tangents. There's 3 of them. If it looks like this. Shav, how do you know that it looks like that? Well, I took Algebra 2. In case, okay, not that, okay, I'll stop. Let's just see where my horizontal tangents are. So remember that a horizontal tangent has a slope of 0. So I'm going to take a derivative because derivative gives me my expression for slopes, tangent slopes, and I'm going to equal that sucker to 0. So here we go. Does everyone see the game plan? Okay, I'm going to take a derivative. Y prime equals, what's the derivative of that? 4. X to the what power? 3. Minus, what's the derivative of 2x squared? 4x, yeah, minus 4x. And the derivative of 2 is 0, right? So there it is. I'm going to equal this to 0. Why am I equaling it to 0? Perfect. So put it for good notes. I'm going to write here. Slope, excuse me. I don't know what that was about. Maybe the drink there. Slope. Yeah, it was a burp, and I was talking at the same time. Man. Slope of horizontal tangent. Yeah, slope of horizontal tangent is 0. All right, you can do this without a calculator. You don't need a calculator for this. I'm going to factor out and I'm going to have x squared minus 1, and I get 3 values, which you're not shocked because this one kind of looks like a W. Yeah, I don't know why I said it like that. Sorry, guys. X equals one value is 0. And then this is the difference of squares. So, or you can just say x squared equals 1, take a square root. X equals, there's two answers, 1 and? So I'm going to say plus minus 1. I'm going to check if I really have tangents at those values. Chop, how do you check? I take my calculator out. Here's my little calculator. And I'm going to type in that equation. What was the original equation? X to the what? 4th minus 2x squared plus 2. All right, I'm just gonna do a regular zoom, a zoom standard number 6, and I'm gonna check. Yep, check it out. I definitely, in fact, have a horizontal tangent at -1. Look, I'm gonna push trace. I'm gonna put -1, and I push enter. Look, you're right there. Don't I have a horizontal tangent there? I definitely have a horizontal tangent at 0 because it's just a. Look at your tangent line. Well, I know I'm not drawing a tangent, but. So look, I'm going to push trace, and I'll put 0, and push enter. Yeah, it's flat right there. I have a horizontal tangent there. And I definitely have a horizontal tangent at 1 right here. Does that make sense, guys? So we're good. Does that make sense or no? All right, let's continue. Let's continue. Well, I guess I'll draw the visual really quick. It's not going to be perfect, though. All right, here's my visual. Not perfect. You have a horizontal tangent there. That's a -1. Horizontal tangent there. 0, and horizontal tangent there at 1. And it should have been symmetric on the y-axis, but mine didn't come out symmetric. That's fine. True story, I got a D in art my freshman year. No, that really is a true story, guys. I'm really embarrassed. It's actually the very first line on my transcript. And so that's why sometimes I'm embarrassed to show. I'm cum laude, but the very first line says D. It says Art 101, and it says D. And, huh? I took art my freshman year at the university, and I thought I did pretty good, but according to my transcript, my professor said my art sucked. So, all right, here we go. A random cue from your textbook. Well, you guys don't have textbooks, but when I type this out, this is the textbook that this district uses. So I put the reference there. It says, find the tangent to the curve y equals x cubed plus x at the points where the slope is 4. What is the smallest slope of the curve, and at what value of x does the curve have this slope? Okay, so it's asking several questions. First, let's do the first. I'm going to go slow. Where does this tangent have a slope of 4? So we're just going to take a derivative, and I'm going to equal it to 4. Not 0, because 0 is horizontal. 4. Cool or not cool? So here we go. Y prime equals what's the derivative of x cubed? Perfect. Plus what's the derivative of x? 1. Yay. Equals, and I want to set that equal to 4. Are we okay? All right, I'm going to solve for x. And those x values are where my slope is 4. My tangent slopes are 4. So I'm just going to subtract 1 from both sides. So 3x squared equals 3. I can divide both sides by, so x squared equals 1. And then finally I take so x, I'll write it over here. X equals plus minus 1. So when x is positive 1 and negative 1, I have a slope of 4. Tangent slope of 4. Are we okay? All right. Now now let's answer the second question. So I'm going to say at x equals 1 and x equals negative 1, comma, tangent slope is 4. So there, I answered the first question. Second question. What is the smallest slope of the curve? Okay, well, y prime, I got to look at my derivative. And I'll slow down. What is the smallest 3x squared plus 1 will ever be? I don't know, Chavez. No, not 3. Not 0 either. This one never equals 0. 1. How'd you get that? How'd you get that, Alvarez?
I didn't say that.
How'd you get that, Marchan?
You can plug in 0 and then
Yeah. If okay, and why'd you plug in 0? You just did? Why didn't you plug in -1 or 1 or something?
Because -1 squared is just going to be 1, then you get 3 plus 1.
Okay, good. What Marchand is saying is this: x squared is always positive if you want to count. No matter what number you put in there, it's going to be positive no matter what. So what Marchand did in her head, she's like, well, x squared is always positive. So the smallest value I can put in for x squared is 0. Because 0 squared is 0, right? Every other number squared is going to be bigger than 0. Every number, like 0.5 squared is 0.25. I know it's smaller, but it's bigger than 0. So the smallest you can put for x is 0. So 3x squared is 0. So what's 0 plus 1? 1. By the way, this graph that I drew here, this is not the original. That is your derivative graph. What is the minimum of your derivative graph? At the vertex. What is that y prime value? Well, that value there is 0, 1, that point, that vertex. But remember, this is my y prime graph. So the minimum on your y prime graph, min on y prime graph, or min value, I should say the word value. Min value on y prime graph is 1. So there it is. That's the smallest value you can have on your derivative. Does that make sense, guys? Okay. What is the smallest slope of the curve? Okay, the smallest slope. So let me answer the question. Here's the second question. Smallest slope on curve is 1. That's the smallest curve. That's the smallest slope you can have. Does that make sense? All right, and let's see. At what value of x does the curve have this slope? Okay. The value of x with smallest slope is at x equals 0. At x equals 0, you have the smallest slope. Are we okay? Okay. I didn't know if I should have included those questions or not because I don't know if we were ready for it or not, but I think we're ready. All right, example 7. Don't worry, we're gonna get more and more tough with power rule. That's the only rule you know right now. So you should not be. We're not gonna complicate things by. In the past, I used to show all 3 rules, and then what do I do? And I would get a whole bunch of answers because you could do this with product. You could, but why would you want to? All right, ready? The only rule you know right now is power rule. That's the only rule. I have this here. It doesn't look. It's not set up in a way that you can use the power rule right now. So you got to do algebra. Algebra is what's going to stop you, not the calculus. Are we ready? So here we go. I cannot solve right now. Go ahead and expand it. The numerator is the difference of squares. If you see that, just write x squared minus 25. If you don't see that, just FOIL it. X times x, x squared. X times positive 5 plus 5x. Negative 5 times x minus 5x. Negative 5 times positive 5 minus 25. Chav, why are you doing this the long way? In case you don't see it. But if you see it, you could have immediately looked. The 5x is 0 out. You could have immediately done x squared minus 25 over x. Are we okay? Okay. Next, Chav, I can't do power rule right now. I have a quotient. It's divided by one term. When you're dividing by one term, you can break it up like this. Y equals, and I'm going to write x squared over x minus 25 over x. Are we still okay? Have I confused anyone? Okay. X squared over x. Don't leave it like that. Simplify it. X squared over x is the same thing as x. Laws of exponents. That's to the power 2. This is to the power 1. You just subtract the exponents. And then I'm going to go ahead and bring this up because I want to use the power rule. So minus, and then when I bring this x up, it's going to be what? 25x to the what power? No, not to the half. I brought it up. Right now it's positive 1, negative 1. Are we okay? I have not taken a derivative. That was all algebra. Here we go. I'm going to put a semicolon to indicate that I'm going to have a new line. I just don't have enough room. Y prime equals, what's the derivative of x? Espinosa, what's the derivative of x? You got this. Not 0. What's the other number that you can think of? Say it loud. 1. If you have the, no, and look, I want you to know it. If you have the equation y equals x, what's the slope of y equals x? 1. Remember that slope, instantaneous rate of change, is derivative. So what's the derivative of x? 1. You won, miss, okay, I'll stop. 1. Okay, what's the derivative of 25x to the negative 1? Negative 25, but negative times the negative is a, so I'm going to put plus 25x, what power? Negative 2. If I told you that I want positive exponents, semicolon, well, I guess I don't need a semicolon to break it. Y prime equals 1 plus 25 over x squared. Are we okay with that? Oh, because I already have, do you see how I already have a minus here? What's negative times a negative? Because I multiplied it, I take that 25 like a negative 25. Does that make sense? Are we okay, guys? Delgado, you okay? Okay. If you want to take a little break. All right, here we go. Laws of exponents. I can't take a derivative right now. So tell me what the square root of x is in exponents. X to the 1/2. Plus, what is the cube root of x as an exponent? Now I'm ready. Y prime equals, what's the derivative of x to the 1/2? 1/2 x negative 1/2. You can, yeah, that's fine. Are we okay so far? Okay. Tell me, Flores, dime. Okay, I'll give you time because I'm going to take a sip of this. Satisfying, refreshing. It was coffee. I subtracted 1 from 1/2.
Oh, you're right.
No, we're good. I still have another term. I'm not done, guys. Plus 1/3 x. Say negative 2/3. Because when you say minus, it sounds like you're subtracting. To the negative 2/3. Are we okay with that? Okay. I don't want to see exponents like that, though. I want them positive, and I want to see radicals. Look, because that's how the answers are going to be. In the AP, they're not, well, sometimes they leave them like that, but usually they don't. Here we go. 1 over, when I bring that x to the negative 1/2 down, that's x to the 1/2, and x to the 1/2 is square root. Yes or no? So 2 square root of x. Cool or not cool? All right. Plus 1 over 3 cube root of, no, not x. No. X what? X squared. Guys, it's x, yeah, we're going to need a law of exponent review. You guys choose a day, preferably this week, so then that means you have your options of either today or tomorrow. I would just put it in your schedule for tomorrow, but it's up to you. Choose a day. All right, so then sometime next week then. 30 minutes after the fundraiser. Yeah, I guess I could. All right, guys, let's keep going. We still got 3 more. Actually, 4 more. Yeah. These are the last ones that we're going to do. Letter C. Here we go, guys. Here we go. I cannot take a derivative just yet. I mean, you can, but let's fix this so we can use the power rule. So here we go. I'm going to bring that x up. When I do that, that's going to be what? Negative 1. Yeah, we're gonna need a review, guys. I'm gonna bring that x squared up. I'm not taking a derivative. I want you guys to notice the notation that I'm not taking a derivative. I only write y prime when I take a derivative. minus 3, and I'm bringing that x squared up. That's x to the negative 2. And then that 75x I don't have to worry about, plus 75x. Are we okay with writing the expression like that? Okay, here we go. Y prime. Now I go ahead and put the prime on the y. I'm taking the derivative now. What's the derivative of x to the negative 1? Negative 1, x to the negative 2. I'm not done. What's the derivative of the next term? Positive 6x to the negative 3. What's the derivative of 75x? Plus 75. All right, let's rewrite this. I'm going to put the equal sign, which is fine, because it's all y prime. Negative 1 over x squared plus 6 over x cubed. That's a 3 there. Plus 75. Tomorrow when you get your circuit, if you don't see this answer, or if you don't, well, I wanted to do the circuit today, but I don't think we're ready. Okay, real quick, time out, because this is actually a big deal here on this one. If this question was on the AP exam, which it wouldn't be this simple, but if this question was on the AP exam and it was multiple choice and you took the derivatives with the power rule and you did not see this answer, are the answer choices wrong? No, we're right. We're right. This is the correct derivative, but how else could they have written it? They could have found a common what? They could have found a common denominator. So, see, it's the algebra that's hard, not the calculus. They could have multiplied, okay, so, you know what, let's do it all together. They could have multiplied this by x over x, and this guy by x cubed over x cubed. Do you guys see that? If they do that, look what you have. Y prime equals negative 1 over x cubed. I'm going to go ahead and write all the details. Plus 6 over x cubed. X over x cubed, sorry. Yeah, tell me, guys, when I make mistakes, tell me. I didn't do that on purpose. I just... Plus 75x cubed over x cubed. So look what that looks like. It looks like this. I'm going to put the positive term first. I'd like to have that first. 6 minus... I guess I should have put the 75x cubed first because that's the highest degree. You don't have to, but 75x cubed plus or minus x plus 6 all over x cubed. That answer choice will probably be on the AP exam if it were asked. But you had the right derivative. You just got to do the algebra. Are we okay? Okay. All right. Don't freak out with letter D. Bam. Laws of exponents. So I'm gonna go slow. I'm gonna go real slow. I'm gonna do sky blue so I can differentiate from the top stuff because I might write a lot, maybe. So this is the same thing as x times x to the half plus 8x to the negative 1. I cannot use power rule just yet. Oh, wait. What is x times x to the half? No. Not x squared. No.
Oh wait.
Yeah, we're gonna need to do law of exponents, guys. When you okay, side note. X squared times x to the cube. Side note. We know that. X squared times x to the cube. What is that? X to the fifth. What did you do? I added. So this is a power of 1, and that's a power of half. So when you multiply x to the, what's 1.5? Don't write it as 1.5. Write it as 3 over 2 plus 8x to the negative 1. Are we okay? That is not the derivative. That is just my original expression. Are we still cool? All right, new line. Y prime equals, what's the derivative of x to the 3 halves? 3 over 2, x 1 half, because you subtract 1 from the 3 halves, And then what's the next term?
Negative
Minus 8x to the
negative 2.
-2. I'm going to fix it. Here we go. Well, yeah, to have positive exponents. So I'm going to have 3/2 with a square root of x on the side. You can also write 3 square root of x over 2. It's all the same. Minus 8 over x squared. Are we okay? All right. We got 2 left. No, you're not. You're not. All right. On letter E, x minus 5 to the 3rd power. If you remember Pascal's triangle, where you use their coefficients to help you out, and then the degrees have to add up to that number of your Pascal's triangle, go ahead and just expand it with Pascal's triangle. If you don't know what I'm talking about, then don't even worry about it. You know that this just means x minus 5 times x minus 5 times x minus 5. That's what it means. Yay or nay? I know that you can do 2 of them really fast. You can do x minus 5 squared really quick. So that just means x minus 5 squared times x minus 5. Are we still okay? Okay, I grouped that on purpose because I know you can do this one fast, because you guys have been doing that for a while now. So how do I do that one fast? Like this, and I'll go ahead and put it down here. So I'm still doing y equals. So x times x is x squared. X times negative 5 is negative 5x, but you're going to have 2 of them, so it's going to be negative 10x. And negative 5 times negative 5 is? So, and then close the parentheses, and you still have this x minus 5. Trav, I don't know how to multiply that. Yes, you do. Take the x squared and multiply it by everything in the other group. So here we go. What is x squared times x? X cubed. What is x squared times negative 5? Negative 5x squared. You're done with the x squared. Drop it. Go to the next one. Negative 10x times x. Negative 10x times negative 5. Perfect. With an x on it, right? Okay. Drop the negative 10x. You're done. You're done with it. Go to the 25. 25 times x. 25 times negative 5. All right, here it is. Y equals, just change the color in a little bit with a different pencil. You know what I mean? For the next one. Y equals, let's see, I only have 1x cubed. And then let's combine negative 10x squared and negative 5x squared. That is negative 15x squared. And then 50x plus 25x. And then minus 125. We're still okay? Yeah. How do we feel? Okay, no, don't worry. We're almost done, guys. We're almost done. Okay, here we go. Let's take a derivative. Y prime equals? What's the derivative of x cubed? What's the derivative of 15x squared? 30x. What's the derivative of 75x? Done. Yeah. That's a constant.
So any base number.
Any constant.
Like one without like any factorial.
Yes.
Or
No. Yeah. Or yeah, it could be pi if the root of a pi is 0. That's a good question. I'm gonna put that in there. All right. Ready for the next one? I'm going to change colors so to not confuse anyone. Okay. When you look at letter F, there's the last one, guys, and then we'll set you loose. You have a, well, we'll tell you, let's not stress you out. Okay. Letter F. I would like for you to recognize it. If you don't recognize it, that is okay. That is what? What is it, Galero?
I think it's the difference of
It is. If you look at it, you're like, hey, that looks like the difference of cubes. Where it's, so this, right off the bat, is just x cubed minus 2 cubed, which is 8. If you don't see that, relax, don't worry about it then. You take that x and you multiply it by everything on the other side. So here it is. If you don't see the difference of cubes, you're going to get the difference of cubes anyways. What's x times x squared? X cubed. X times 2x. 2x squared. X times 4. 4x. All right. That's it. You drop the x, go to the negative 2. Negative 2 times x squared. Negative 2 times 2x. Negative 2 times 4. Look what zeroes out. Do the 2x squared zero out? Do the 4x's zero out? Are you shocked that you got x cubed minus 8? No. Here we go. Yes. From algebra, a cubed minus b cubed. Are you talking about difference of squares? Or difference of cubes? That is just a minus b times a squared plus ab plus b squared. Yeah, I'll put it where we can see it better. Let me put it where we can see it better, guys. I'll write it right here. A cubed minus b cubed is a minus b, a squared plus ab plus b squared. And I'll write the other one as well. A cubed plus b cubed is a plus b, a squared minus ab plus b squared. Okay. All right, here we go. Y prime. What's the derivative of x cubed? What's the derivative of 8? There it is. That's it. How do we feel? All right. So right now, we just need a lot of practice, and that's what I put on Delta, a whole bunch of practice.
What's due today, right?
I have it due today, yeah, I think. The other one is not due till like Sunday, but that's until we get more experience.
Crazy. I was doing my Delta math, like in my dream, and then I woke up, but I didn't realize it was.
So let's continue. Notes 9. This is the product rule. We're going to go really slow. This is a rule that Lopez tried to teach you guys. Delta has the order reversed, and that's for a reason, because they like to make you guys into, well, okay, I'm not talking smack about Delta, so for you YouTube fans. You know how Delta does like formulas, and they give you formulas, and they want you to just, so I feel like, and don't get me wrong, Delta is not wrong because it's a product. Delta reverses the order. So what I'm trying to tell you is, I prefer you have this order, but if you want to reverse the order, because there's a plus symbol in the middle, it's not going to matter. If you get used to Delta's way, that's fine. But I prefer that you use this order. So how do you say this order? So the product rule, I have u times v. So the way you say product rule is first times derivative of the second plus second times derivative of the first. So say it with me. First times derivative of the second plus second times derivative of the first. One more time. First times derivative of the second plus second times derivative of the first. So when you take delta in a little bit, you're going to see that their order is reversed, but it's the same. They do this one first, and then they put this one in the back. But because there's a plus symbol, there's no consequence. They do that because it's easy to memorize the quotient rule afterwards without making a mistake. But I prefer, we're not learning rules. Like, well, I mean, we are right now, right? But here we go. First times derivative of the second plus second times derivative of the first. All right, so before we even take a derivative, right now we just know one rule. We know the power rule. Can someone open Espinosa, therefore? Leave the door slightly open. Leave the door slightly open. Yeah, Montalongo is the one that closed it. Hey, Montalongo, if you're watching my YouTube video. Okay, yeah, that's good right there. All right, so this one right here, by now, we should be all pros at taking a derivative. We can't take a derivative right now. We have to do algebra first, right? So let's just do algebra first by expanding it. X squared times x cubed, that's x to the fifth. X squared times 3, that's 3x squared. Then 1 times x cubed, that is x cubed. And then 1 times 3, 3. So let me put it in order. So here it is, me putting in order from highest degree to lowest degree. X to the fifth plus x cubed plus 3x squared plus 3. All right, here we go. Ready? My derivative, f prime of x is equal to, what's the derivative of x to the fifth? 5x to the fourth plus the derivative of x cubed. Plus the derivative of 3x squared. 6x, yeah. And the derivative of 3 is 0, right? All right, so there's my derivative. Hopefully by now we're pretty good at this because we've been doing this for about a week. All right, so now let's do this rule with the product. We're still going to have to do some algebra, but let me change. If you have colored pencils, now's a good place to change your colored pencils or change your ink. So here we go. I'm going to rewrite f of x squared plus 1 and x cubed plus 3. Okay. I'm going to underline what my u is, and I'm going to double underline the v. So what I'm trying to say is I'm underlining the first, and I'm double underlining the second. Okay. And I'm going to go slow, guys. F prime of x equals, according to my rule, it's first. So I write the first, my first underline again, x squared plus 1. Times derivative of the second. So what's the derivative of x cubed plus 3? Perfect. Close it. I put a plus symbol. Is everyone okay so far? Plus the second, so the double underline, x cubed plus 3 times derivative of the first, which is 2x. Can everyone get to there? All right, you're done. You're finding the derivative. That's the derivative. Now you just do algebra. So I have that 3x squared. I'm going to distribute it like that. So 3x to the fourth plus 3x squared. I don't see any mistakes right now. Plus, I'm going to distribute this 2x like this. 2x times x cubed, that's going to be 2x to the fourth plus, what's 2x times 3? 6x. Are we okay so far? Okay, let's put it in order. Combine like terms with the highest degree first. I see a 4, so what's 3 plus 2? So 5x to the fourth, and then let's see, I see an x squared plus 3x squared plus 6x, and there it is. All right, now look. Did we get the same expression when we took the derivative earlier? So there it is. So this is supposed to be like your validation. Like, okay, product rule works. So whenever you have something that's a product, you can use product rule. This is not a proof. The proof actually does not look anywhere remotely close to this, but yeah. Cool or not cool? Okay. Yeah, ask. Ask again. Everything in blue is the product rule. Well, the product rule really is just up to here. That in black is the product rule. And then everything after that black line is just algebra. So, what's the what? The red part is just using the power rule. Yeah, I did the algebra up here, and then I just took the derivative of this expression with the power rule. So the one in red is power rule. The one in blue up to this line in black is product rule, and then after that is algebra. Cool or not cool?
So you would do this to kind of like check to see if like, you were right?
No, I'm just doing this just to validate that it's a correct derivative. You would never actually, if you have a product and if you think it's easier to just do power rule, you would just do power rule and then leave it alone. You wouldn't go back and be like, oh, now let me use the power rule. Like there is the derivative and then use the derivative for whatever you got to use. All right, here we go. This time they force us. It says let y equals uv be the product of the function u and v. Find y prime of 2. And they give us all these values. I'm going to go slow. So I'm going to write y equals uv. So I'm going to write y prime equals, I'm just doing the rule right now. I'm not plugging anything in. First, u times derivative of the second. You can either write dv, or actually, you know what? We're just going to use the primes. So derivative of the second, v prime. Plus the second, v, times derivative of the first. So u prime, perfect. I haven't done anything. Are we okay so far? So this is the only calculus. That's it. And the only calculus is just using the rule, product rule. What is this called? Product rule. So here you go. Y prime of 2 is equal to u of 2, which is 3. Should I write u of 2 first? Do you guys want to see that? Okay. U of 2 times v prime of 2 plus v of 2 times u prime of 2. All right, let me put the little arrow. So here we go. U of 2. U of 2 is 3. What is v prime of 2? V prime of 2, no, it's over here. V prime of 2 is 2. Plus v of 2, what's v of 2? 1 times u prime of 2, which is -4. So y prime of 2 is nothing more than 6 minus 4. So y prime of 2 is just 2. How do we feel, guys? Nothing crazy, right? Okay. All right, so that's the product rule. Now we're going to learn one more rule. We're going to use the product. This is called the quotient rule. You use it when you have a quotient. Child, what's a quotient? Whenever you're dividing. Are we okay? All right, there's a little song. We'll teach you the song in a little bit. Let's talk about this derivative first. I want you to notice that they have v and then du dx. So it's bottom times derivative of the top minus top times derivative of the bottom over bottom squared. Yeah, that might be too much. I'll sing you the little song in a little bit. So notice u over v, the u's in the top, the v's in the bottom. Bottom times derivative of the top minus top times derivative of the bottom over bottom squared. Some people like that. Just give me the definition. Bottom derivative of the top minus top derivative of the bottom over bottom squared. And then some people prefer the little song. Ready for the little song? So low means bottom, and then high means top, right? Because high, what's on high. And then if you hear me say d high, that means derivative of the top, or d high. And if you hear me say d low, that means derivative of the low. That makes sense? So low d high minus high d low over low low. All right, yeah, well, let's all do it. Okay, ready? You've probably seen it on TikTok, you know. Low d high, say low d high. Low d high. Minus high d low over low low. All right, let's do it again. Low d high minus high d low over low low. All right, so there it is. So what did I just say? I said low d high, so bottom, derivative of the top, minus high d low, top, derivative of the bottom, all over low low, that means bottom squared. Does that make sense? So let's put it to good use. So look, what is low, what is high? Well, high here is x squared minus 1. Low here is x squared plus 1. So I'm going to go slow, guys. F prime of x equals, and I always start with low, yeah. Yeah, whenever, what's a good way to memorize it? When you go out, walk into an office building, you always have to, like if there's elevators, you always have to walk across. So that's the bottom. And then take the elevator to go up. So yeah, you always start with low first, or drop it down to the floor. Oh yeah, that was dumb. Yeah, no dance moves. Okay, low. No. If I drop to the floor, I won't be able to get up. I mean, put some music, and maybe I have enough energy to do one. But all right, here we go. Sorry, guys. Low d high, bottom times derivative of the top. So low x squared plus 1. That's what I have in the bottom. D high, so that means derivative of the top. So what's the derivative of x squared minus 1? 2x. Plus or minus? Minus. The quotient rule is always minus. Minus high, so x squared minus 1. D low. So what's the derivative of x squared plus 1? Another 2x. All over low low. So what's the derivative of x squared plus 1? I mean, sorry. I just write x squared plus 1 and I square it. That's it. There's no derivative. Caught myself. So low d high minus high d low over low low. If you don't like all these highs and lows and d highs and d lows, just go bottom times derivative of the top minus top times derivative of the bottom over bottom squared. And I know some of my BCers, at least one of my BCers is like, I don't like the high D and the low D and high and low. And so one of my BCers is like, what is the other one? Like low bottom times derivative of the top minus top times derivative of the bottom over bottom squared. One of my BCers is like, I like that. So she goes bottom, derivative of the top, minus top, derivative of the bottom, over bottom squared. So if you like that, just say that then. No big deal. Yeah, so one of them prefers, one of those 5 prefers, doesn't like the song. One of those 5 prefers just plain English. Bottom times derivative of the top, minus top times derivative of the bottom, over bottom squared.
Which one?
I can't rat on them. You tell them. Hey, which one of you likes? Which one of you hates low D high high D low? Like, just ask them. All right, here we go. Usually you don't want to leave it like this, guys. Usually you want to simplify, but if it's just asking for derivative and it's free response, you can just leave it like that. I believe in today's delta, I just put the easy ones. I just put level 1, and I believe the level 1s you just leave it alone. Like you don't have to simplify, which is probably what we need right now, anyways, right? So on the delta that you have, you don't have to simplify everything. But right now, let's simplify. Let's practice. So distribute that 2x like this, guys. 2x cubed plus 2x minus. So here's where a lot of you guys mess up. If you mess up with that minus, just put a giant parenthesis like that so you know that you're distributing to all of that. 2x cubed minus 2x. I haven't done anything crazy. Yeah, if you can see it, you don't have to do all that steps. Then distribute that negative. So what's 2x cubed minus 2x cubed? 0. What's 2x plus 2x? So this really is 4x over x squared plus 1, close it squared. And you don't have to expand the denominator. It's understood that that's simplified. The numerator? Yeah, the 2x is positive, yeah. How do we feel, guys? Yes, ask you. No, I did. I did zero out. That's why it's not there. The 2x cubed and the negative 2x cubed zero out, so they're not there. There's no, I mean, I guess I could put 0x cubed, but yeah.
Yeah, it was just confusing me because they're all 2's.
Yeah, the 2x cubed zero out, and then this 2x turns to a positive, and 2x plus 2x is 4x. Yeah, ask. What were you going to say, Alvarez? You were going to say something, or you started saying something? What? Did I see Pokemon? Oh, I thought I heard Pokemon. All right. I like Pokemon, by the way. All right, anyways. Example 11. Which rule should I use? Find the equation from the line of tangent to the curve of x squared plus 3 over 2x at the point 1, 2, and then support your answer with Desmos. Okay. Because some of you are writing tangents like this. So I have a curve, and you tell me, oh, the tangent at that point is that line. Those are not tangent lines, guys. And then some of you are actually telling me the correct tangent line, but then you tell me that the normal line is, oh, that's my normal. And I'm like, guys, the tangent and normal are perpendicular to each other. That does not look like a 90-degree angle. Come on, guys. All right, let's go slow. You can, if you want, use quotient rule, but do you have to use quotient rule? That's not the only rule that you can use here. You can do algebra and then use the power rule. It does not matter which one. It does not matter. Look, we'll do both so you guys can be. So I'm going to do power rule with red, and I'll do quotient rule with sky blue if you guys want to color code. So using power rule. So do algebra first. So I have x squared over 2x plus 3 over 2x. One of those x's cancel out, so I have 1/2. I'm going to put the x on the side so it's easier to take a derivative. Plus, and I'm going to bring that x up. I'm going to write it like this. 3/2 x to the negative 1. Am I okay? I haven't taken a derivative, guys. I just rewrote it. Yeah, I'm telling you, we need a day of laws of exponents. One of the x's canceled out in the first term, and the x in the bottom, I brought it up, so it's x to the negative 1. We're okay so far? All right, here we go. Y prime. What two things do I need for a tangent line? Point and slope. Do I already have a point? Yes.
I'm sorry.
What happened, miss?
So I'm confused how you got x squared over 2x equals 1/2 x.
One of the x's cancels out. And it's 1/2 x. I'll show you. See, like this, miss.
Yeah, you didn't write this. I was like, huh? Wait, what happened?
X over 2 is the same thing as 1/2 x. Yes, you're good. You're good. You don't have to apologize. All right, here we go, guys. Y prime. What's the derivative of 1/2 x? 1/2. Just half. What's the derivative of 3/2 x to the negative 1? Negative 3/2 x to the negative 2. So y prime evaluated at 1 is 1/2 minus, I'm going to bring that x to the negative 2 down, 3 over 2 parenthesis 1 squared. Right? Because I'm doing the derivative at 1, it's x squared. So I have 1/2 minus 3/2. And usually, I know some of you are probably like, Chav, I could have done this in one step. You're right. I'm just trying to show as many steps as possible right now. 1/2 minus 3/2. 1.5 minus 1.5, that's going to be, so negative 1. Are we okay with that right now? All right, that's my slope. Here's my tangent line. Y minus 2 equals negative 1 parenthesis x minus 1. Do I have to simplify this? Do I have to get it in y equals mx plus b? No. If it's multiple choice, then I guess we have to. But if it's free response, you can leave it like that. Cool or not cool? Yeah, right now we'll see the tangent line in Desmos. Is this a live link? Let me see. Dang it, it's not a live link. I need to pay for that. I need to pay for that to have that link be a live link. And I'm not going to pay $5. No, I'm kidding. All right, what's up, miss? Yeah, for Dropboard PDF. Say it again. Yes, I use the power rule. Negative 1 times 3/2 is negative 3/2. And then what do you do with that degree? You subtract 1. So negative 1 minus 1 is negative 2.
Oh, that's what I was looking at.
Cool or not cool? All right. All right, guys. I'm going to do it with sky blue. You guys ready? With sky blue. And here I'm changing. I'm going to use, what rule did we say we're going to use? Quotient rule? So here it is. Y prime equals, what's the derivative? Well, how do I get the derivative using quotient rule? Yeah, low d high. So bottom times derivative of the times 2x plus or minus? Minus. So x squared plus 3 times the derivative of the, so 2. Oh man. All this over. Yeah. Low. Yeah. 2x times 2x. Yeah, I got you, miss. Are we okay with that? All right, so here we go. I'm going to get y prime now. Y prime at 1 is equal to, I'm just going to plug in 2 times 2. What's 2 times 2? 2. Yeah, hold on. Let me click on this really fast. Yeah. 2 times 2 is 4. So 4. Are we still okay? Minus, I'm plugging in a 1 right here, right off the bat, guys. 1 squared is 1. 1 plus 3 is 4. What is 4 times 2? 8. All over. 2 times 1 is 2. And now I'm squaring it. What is 2 squared? And look at that. OMG.
That's just negative 1. Hold up. Oh yeah, it's 4 minus 6.
Hold up. Wait a minute. That's a slope. At 1. So y, so here's my tangent line. Minus 2 equals negative 1 parenthesis x minus 1.
Oh, so you just did it in wait.
Yeah, yes. The one in red is power rule. The one in sky blue is quotient. Oh, you put product? No, power. All right. I said let's check it out on Desmos, so let's check it out on Desmos. Desmos. I'd like to think I'm pretty serious. All right. What was my equation? All right, guys, focus, 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 focus. What was my original equation, the function? X squared plus 3 over 2x. All right, check it out, guys. Look at my tangent line. Ready? Oh, at what point did I want it at? 1, 2? 1, 2, because I want to see that point. Okay. Does everyone see that point? Look how awesome Desmos is. So there's my point, 1, 2. Look how my tangent line is going to look. Hopefully by now we have an idea how it's going to look. It's going to look like that, right? All right. Give me my tangent equation. Y minus 2 equals, and then negative 1, parenthesis, x minus 1. Look at that. Beautiful. That's a tangent line, guys. Not, okay, yeah, I'll stop. But I'll probably still remind you guys, even as you guys get close to graduation. Maybe I'll even put it in your graduation card. Like, like, hey, you finally learned how to draw a tangent line. You're ready for the world. Go apply for a loan. Tell them you know how to do tangent lines. See what they tell you. Okay. All right, here we go. Let's continue. All right, don't freak out, guys. Don't relax. Don't freak out. Go to the next page. Yeah, you like that? I typed all this out myself. This is exactly how I talk. Guys, cardinals, we can always take higher order derivatives.
Yeah, but I've never heard you say
We're not limited. I said cardinals all the time. Birds of a feather fly together. Okay. All right, here we go. So all you got to know is this. Y prime stands for dy dx, and I think we know that, right? That means the derivative of y with respect to x. Y prime prime stands for the second derivative. So it means dy prime over dx. You rarely ever see that. This is what you see. So y prime prime, because you don't, y prime means first derivative. First der. Y prime prime means second derivative. So y prime 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 means third derivative. We can take as many derivatives as we want. But remember, a derivative means instantaneous rate of change. So eventually, taking a fourth or fifth derivative is not going to make any sense. I mean, it can, I guess, if something really is moving, maybe like a piston, because piston does, yeah. But like, if it's position velocity graph, the slope of that is velocity, and then if you have a velocity time graph, the slope of that is acceleration. And then if you have an acceleration time graph, the slope of that is called the jerk. So that's why you see a lot of math jokes that say you're the third derivative or you're the derivative of acceleration, you're a jerk. Anyways, we'll get there when we get there. I think I might say it in here. All right. Here we go. You guys ready? So this is the third derivative. Relax. So here's how you say any nth derivative. D with an n on it, y over dx to the nth power. That means nth derivative. So if you want the fifth derivative, you would write it like this. d5 y over dx to the fifth. That means fifth derivative. Yay or nay? Now sometimes they do not write the letter y, and you'll just see it like that. Relax, it just means to take the fifth derivative as well. Cool or not cool? Your professors, especially if you're in physics, sometimes they use the capital D, and then they'll put like a subscript 3, and that means the third derivative. But we'll wait for that issue when you get to university physics. Right now you're not at the university, so we don't have to worry about that. And only the STEM majors have to worry about that, because if you're not a STEM major, you're not going to go into calculus-based physics. Yes, miss. Well, remember, so if we have, what is a derivative? An instantaneous rate of change. So if I have a position time graph and I tell you find me the derivative. Well, the slope on a position time graph is distance divided by time, which is velocity. What if I take a second derivative? Well, that's the slope of the velocity time graph. Yeah, the slope of the slope. And if you take a third derivative, it's the slope of the slope of the slope. Instantaneous. If you because now you said the word tangent. A tangent is just a linear line. It's a slope of the slope. So the first derivative is, yeah, it is. That first derivative tells you where the slope of your tangent is for any x value. It's an expression that tells you the slope of your tangent line for any x value. Yeah, don't worry, you will. You will. Right now, we're just going to practice. All right, guys, here we go. You guys ready? Yes. This says find the first four derivatives of this expression. We're going to go slow. Here we go. Y prime equals, I'm just using what rule? Power, just the power rule. What's the derivative of x cubed? What's the derivative of 5x squared? 10x, put the minus because of that. And the derivative of 2 is 0, so there it is. That's my first derivative. Are we okay? All right. What's my second derivative? Put 2 primes because we're well. You know what? Let me put all the symbols that we can use. Don't worry. I'm not erasing. That's the correct answer. I'm just going to put all the symbols we can use. Y prime, which equals dy dx, which equals 3x squared minus 10x. I just want to use all the different symbols. All right. Y prime prime. Here's the what else? How can I can't even talk. d2y over dx squared. That means second derivative. Equals, what's the derivative of 3x squared? 6x minus 10. Yay or nay? Okay. Y prime prime prime. There's 3 primes there. Equals d3y over dx cubed. That means third derivative. The third derivative is 6. Usually, once we go higher than 3, you start either using prime numbers. Use prime. Why did I say prime numbers? Roman numeral numbers. Sometimes they put the number 4 in parentheses. That does not stand for. Sometimes they do this. They put the 4. It's not y to the 4th. It's the 4th derivative of y. So it does depend. I'm going to use Roman numerals. There. Is equal to, because that kind of is like a Roman numeral. d4y over dx to the 4th, which equals 0.
So that's what you mean by after starting to fourth or fifth doesn't make sense.
Unless you have something that's a sinusoid, then it won't be a 0, like a spring or something. All right. When you get to physics, I know this one from Trinity for sure. When you see y with a little dot on the top, in physics, that y with a dot means y prime. Y dot dot. I had at least one student like, what is this with dots? Like, miss, those are derivatives. You know this. And she's like, oh, okay. Because I think she's a physics major, but that was her freshman year. All right. All right, here we go, guys. We're testing to see if you know all 4 of them. You guys ready? Well, there's only 3 of them. Product. There's only 3 rules that you know right now. Product, quotient, and power. That's it. That's all you know. Power, product, quotient. That's all you know. All right. Letter A. What rule? Let's read the directions here. Suppose that focus, guys. Suppose that u and v are functions of x that are differentiable at x equals 0. And that u equals that, u prime of 0 equals negative 3, v of 0 is negative 1, v prime of 0 is 2. Find the values of the following derivatives at x equals 0. So they want me to find the derivative. All right. You guys ready? What rule do I got to use for letter A? The product rule. Tell me the product rule.
U times the derivative of v.
Yeah, first, I'm going to the second, plus v
times the derivative of,
Perfect. Yeah. Yeah, you can say that. uv prime plus vu prime. You can say that.
Oh, okay. I was like...
All right, make sure that your u's look like u's and your v's look like v's, because sometimes your v's and u's look like the same. What's up?
Make sure they're round and one's
Do I have to what? Well, they're going to come natural to you because we're going to be doing it so often. You get no formulas on your exam, miss. Like on your AP exam, you get no formulas. All right, here we go. Ready?
Yes.
So they want it at 0. So u of 0, what's u of 0? 5. What's v prime of 0? 2. Plus, what's v of 0? -1. And what's u prime of 0? So that is 10 plus 3. So my final answer is 13. How do we feel? Okay. Are we okay? All right. Here we go. Letter B. I'm going to put the equal sign. I'm going to start. So you guys tell me, what do I write first? Low. So I write what letter first? V. Now what do I write? So u prime minus u high. So v prime. Perfect. Now we're just plugging in numbers. You're done with calculus. Calculus is just that definition. If you feel like you're being Chav, I'm being a robot. Well, we're using a definition, so we kind of are. Chav, can you show us the derivation? The derivation of this, we can always do a proof, but I've done the proofs before with previous classes, and I can tell you that all I get is confused faces. So no, like, where did this come from? If you're wondering where this come from, all this came from the limit process. Do you remember when we did the limit as h approaches 0? So we did the limit of a quotient, and this is the property that came up from that limit when we did that limit process. Are we cool? So do you guys still want to see a proof, or are you guys okay with that? Okay. Yeah, I'm telling you from years past, from years experience, it's better if we don't do the proof. But if you guys want to do it, we can do it. All right, here we go. So I'm just plugging in numbers now. So v of 0 is -1. So let me see if I can fit it all in here. What's u prime of 0? U prime of 0. -3, no? Minus, and what's u of 0? 5. Times, what is v prime of 0? 2. All this is over v of 0 squared, so -1 squared. So let's see what we get. -1 times -3 is 3. Minus 5 times 2 is 10. Let me know if I made a mistake, guys. Everything okay so far? Over -1 squared, which is 1. So 3 minus 10, -7. So letter B is -7. Are we? Why what? Well, one was a product, the other one's a quotient, so it's going to be a different number.
Oh, I thought they were. I thought they were gonna like equal each other.
No. This is a quotient. The other one was product.
Oh.
You know what I mean? Like, see, that's UV. This one's U divided by V. So they're going to be different. Do you have a different expression? Right. Look at letter C. Letter C is not the same as letter B. Do you guys notice that? So you should not expect the same answer. It's going to be a different answer. All right, here we go. I'm going to change the color so that way we don't, get everything confused. Like, oh, that's that. Okay. So what do I put first? So U, V prime, minus V, U prime. Perfect. Now let's plug in our numbers. What is U of 0? What is V prime of 0? Minus what is V of 0? What is U prime of 0? All over, what is U of 0? So let's see what we get. So we get 10 minus 3 over 25. So my final answer is 7 over 25. Are we okay? And let me do this one in black. All right, so sometimes after doing the product and quotient, kids get confused with letter D. It's just okay. So let's see, let me write this down here on the side. D dx. If I take the derivative of y, we say that is just dy dx. Right? Okay. So d dx, if I take the derivative of v, what do we say? Yeah, dv dx. So don't freak out. I'm taking the derivative of 7v. You can either write 7v prime or you can write 7 dv dx. It does not matter. 7v prime minus the derivative of 2u is just 2u prime. Yeah, 2u prime. Are we cool? Any questions on that, guys? Okay, here we go. 7 times v prime, which is 2, minus 2 times u prime, which is, let's see, 14 plus 6. Is that 20? How do you feel? So all we're going to do now is practice taking derivatives. Log into Delta. We'll give you a handout tomorrow, but today is just practice. And there should be the easy ones, guys. There should not be anything extreme. Let me know if you run into issues.